An ecological system is vulnerable to destruction from the introduction of plants or animals outside that system. For example, when a non-native plant is introduced into a new area, it usually does not have its growth checked by the environment. With unlimited food and no predators, the non-native plant grows exponentially. Is that word important to us? Yes. Quickly covering, killing, and replacing the endemic native plants. Such a plant is the water hyacinth, which has been called the worst aquatic plant in the world. It is native to South America, but is now part of the lakes, rivers, and streams in most of the southern United States. You know how sometimes we make up stories to be able to do math about it? This is real. Okay, this is real. Now, some of the math that we're going to have to do is more of an estimation, but it's based on the real water hyacinth plant. Okay, so just to make sure you understand, a water hyacinth is a plant. Do you understand that? It's a plant that grows in and near and on the water. Okay. The water hyacinth is said to have been introduced into the United States and Louisiana at the World's Industrial and Cotton Centennial Exposition of 1884 and 1885. A Floridian went home with water hyacinth plants and later released them into the St. Johns River. From this beginning, water hyacinths now cause problems such as forming impenetrable mats of floating vegetation. What does that mean? Impenetrable mats of floating vegetation? So the plants are on top of the water, right? Yes, it's very similar to that, right? So all the plants are together. Can boats pass through the area where the plants are? No, not without damage to the boats, right? Okay. These block boat traffic, prevent swimming and fishing, and prevent sunlight and oxygen from getting into the water. Is it important for sunlight and oxygen to be able to get into the water? Yeah, hugely, right? Okay. Perhaps the worst effect of the water hyacinth is a reduction of biological diversity in waters which it inhabits. Okay? So water hyacinths double in 6 to 18 days. So if I started with 2 and somewhere between 16 and 18 days, how many am I going to have now? 4, right? Because it's doubling. Does that make sense? It doubles the number that there was in this many days. For the purposes of our investigation, let's consider that the number of water hyacinths double in 12 days. Why do you think we chose 12? Yeah, it's just right in between these two, isn't it? Okay, kind of in the middle, an average. Also assume that there is unlimited food and that there are no predators. Suppose 4 water hyacinths were put into the St. Johns River. In question number 5, you will make a table to figure out how many water hyacinths were produced from these 4 at a given time. Determine within your group, right now I want you to have some discussions with your group, the important information in this problem that will help us determine the number in just a minute. Okay? Discuss with your group what the important information is. All right, Kirsten, can you tell me one thing that you think is important information from this paragraph? Okay, so unlimited food, that's one thing, right? One important thing. Ethan, can you tell me another important thing? Water hyacinths, so they will double in 12 days? That's important. Yes, I agree with that. Sierra, can you tell me something else that's important? So we started with, right? How many we start with? That's important. So we started with 4 water hyacinths. I think there's probably one more. I mean, there's other important things in this paragraph, but I think there's one like really important thing left in this paragraph. Anybody know what it is? No predators, right? No predators. Yes, it doubles in 6 to 18, but remember we're choosing 12. Okay? We're choosing to talk about 12. Is everybody okay so far? Okay. After 4 doubling periods, how many days will have elapsed? After 4 doubling periods. How many days are in a doubling period? 12. And how many doubling periods am I asking about? 4. So what am I going to do with those two numbers? So 4 times 12. And 4 is because that's what it's asking for, right? And 12 is because that's how many days in a doubling period. And what is 4 times 12? 48 what? Look, how many days, right? So why didn't I just write 48 from the beginning? Yeah, it does, right? It says to justify your answer. It says show your work to figure out exactly how we're figuring these out. We have to justify how we're getting our answers, right? So now I was a little bit lazy and just drew a 4, an arrow from the 4, because I'm like, this is what it's asking me for, 4 doubling periods, and then 12 days in a doubling period. Are you okay with that? So 48 days. Okay? Okay, let's see. After 96 days, how many doubling periods?
8.
So how are we going to figure that out? 96 divided by 12? Because 96 is what we started with, and 12 is what again? Is it okay if I go ahead and just draw an arrow to there? Days in a doubling period? So what is 96 divided by 12? 8 what? Doubling periods. In 60 days, how many times will the water hyacinth population double? Is that asking me a different question, number 3? Or the same question as number 3? Same question, but different words, right? It's asking it in a different way. So why is this important to me, that it asks it in a different way? Yeah, you got to be able to know, right? You got to be able to read the words and figure out what it's asking, right? So 60 divided by 12? 5 what?
How
many times? So 5 times there's been a doubling period? Are you okay if we write 5 times? Okay. What about 120 days? 120 divided by 12, so 10 what? Times. Okay, so far? So now I talked a little bit about number 5 before. It said we were going to complete a table, right? So here's the table. God bless you. So is it all right with you if we talk about these first 2 columns first? How are these 2 columns related?
That's the doubling period.
And so how many days in each doubling period? 12. So how do I get from this column to this column? Multiply by what? 12. How do I get from this column to this column? Divide by 12. So what we're given is the doubling period column. So how do I figure out how many days there are?
3 times 12.
Times 12, right? Or times it by 12, right? So what's 3 times 12? 36. What's 4 times 12? 48. And 5 times 12? And 6? And 10. Yeah, we skip, right? It's not 84, is it? Okay, 120. But remember, we were going from this column to this column, so we multiplied by 12. But how do you get from this column to this column? Divide by 12. Everybody okay with that? Okay, let's look at our process column. At 0 days, we had 0 doubling periods. Does that make sense? So why is this a 4? That's how many I started with. Exactly right. Okay, that's how many I started with. So after 1 doubling period, do you understand why it's 4 times 2? Because I doubled it. Exactly. So after 2 doubling periods, I'm taking what I had before, which was 4 times 2, and I am doubling it. After 3 doubling periods, I'm taking what I had before, which is 4 times 2 times 2, and I am doubling it. After 4 doubling periods, I'm taking what I had before, 4 times 2 times 2 times 2, and I am doubling it. happen to be seeing a pattern yet?
There's as many twos
As many twos as doubling periods? So could I say 5 times 1, 2, 3, 4, 5? Like that? I mean, sorry, no, that was on me. 4. I was pointing to the 5 and trying to write a 4. That's hard. Not really hard. It just takes some brain power, right? Okay? So, but isn't that the same thing as I was saying before? Aren't these two things the same? And then I doubled it? Okay? So this is a 4 with how many 2's? 1, 2, 3, 4, 5, 6. And this is a 4 with how many 2's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We talked about the next question I'm about to ask you I think the last time we talked about it was in August. So whether you remember or not, that's okay. Okay? But do you remember me telling you why some mathematician developed exponential functions? Or exponential notation? Because he was lazy. Right? That's how a lot of stuff in math was created, because mathematicians were lazy and we were tired of writing 4 with 10 2's after it. Right? When we could write a 4 times 2 to the second, because there's 2 2's. I could write 4 times 2 to the third because there's 3 2's. Do you see how this is intelligent? Right? So 4 times 2 to the fourth, and 4 times 2 to the fifth, and 4 times 2 to the sixth. Does the exponential version have any relationship with the doubling periods? Oh, okay, that could be helpful, right? And 4 times 2 to the 10th. Okay, so 4 times 2 to the 0. Well, what's 2 to the 0? Because anything to the 0 power is? Oh, guys. Anything to the 0 power is what? 1, right? It's 1. Anything to the 0 power is 1. So what's 1 times 4? Well, think about it. If it was 0, what's 0 times 4? 0. It's not 4, right? So think about it. Use your brain when you're thinking about stuff like this, yes? So 2 to the first power is what? 2 times 4? 8. So help me fill in the rest of the table. 2 squared is 4, times 4 is 16, and then 32. Because another thing that's happening is, what am I doing with these numbers? Doubling them, right? And it works all the way until where? Until now, right? 4,096. That's a lot of flowers. Right? I mean, I think a dozen is a lot. Right? When I get flowers, that's a lot of flowers. 12, I think, is a lot. And we're saying after 120 days. So how long is that? 4 months? Ish? After 4 months, there is 4,096 flowers. I want you to cross these out. We're not going to fill them in, okay? They just took this table and copied it right here to make it a little bit easier on us, okay? So what if the number of days that I know is n, like a variable, right? Well, how did we say we got from here to here? We're going from days to doubling periods. Divided by what? 12? So n over 12? And didn't we say the exponential version was related to the doubling periods? How? How was it related? It was the exponent, right? So the total number of water hyacinths is going to be 4 times what? 2 raised to what power? N divided by 12, right? That's the doubling periods, isn't it? The exponent is the doubling periods. The exponent is the doubling periods. About how many days would it take for there to be more than a billion from the original 4? Hey, can I borrow that real quick?
Jump.
No, I don't want him jumping. Doesn't need to hurt his ankles or anything. Thank you. So let's see. There's other ways to get here besides this way, right? But we'll go this way for now. 4 times 2 raised to the, what did we say? X over 12? Yeah? And so I can go look at my table. So Control T. What am I looking for in my table? A billion. Okay. So right now I'm at 4. 5, 10, 30, 40, 50, 60, 70. Oh, geez. 200, 300, 400, 500, 600. Okay. Every time I try to start to count, it just gets faster real quicker, right? Why is that? It's because it's exponential, right? It gets faster and faster really fast. Okay, so I'm here so far. Where am I? 92,000. Okay, so I got to go to a billion. So I'm at 200,000. You think so?
Something like that.
Okay. I don't know. Let's see.
That looks like 11 million, a million at least.
1, 2, 3, 1, 2, 3. 1, 2, 3. So I'm at 11 million.
That's a lot.
Okay.
Still got 100 million.
So now I'm at 100 million.
200. 300. 400. 500. 10. 10. You're almost there. That's a billion.
So read the question again.
And 300.
About how many days would it take for there to be more than a billion?
About 300.
About 335 days. 335 days. How many years is that? In less than a year, I have a billion flowers?
Wow.
Wow. That's less than 1 year. Using your formula, how many water hyacinths would there be after 3 years? Well, what do I have to do first? Because how is my formula set up? In days, right? So what do I need to know?
How many days are
How many days are in 3 years? So how many days are in 1 year? 365. I know that there's 366 this year. It's okay, right? When does that extra day happen, by the way? Tomorrow, right? Tomorrow. So times 3? 365 times 3 is what? 1,095. Here you go. So what do I do with that 1,095? What is that? That's my n, right? So 4 times 2 raised to the 1095 over 12. $1.1777 times 10 to the 28th. Do you see on your number toward the end there's a capital E? Do you see that? You remember what that means, right? That means times 10 to that, right? It's in scientific notation, so this is what it is. You can write this if you want, but you don't have to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 1, 2, 3, 1, 2, 3, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so this is thousands, this is 100,000s, this is millions, billions, trillions, quadrillions, quintillions, sextillions, septillions, octillions. 11 octillion flowers in 3 years. I don't know about you, but that seems like a lot to me.
Imagine having that many daughters.
So here is what I need you to think about real quick, okay? Because I don't, even up here in this question right here, a billion, I have trouble comprehending what a billion is. I have trouble comprehending what a million is, right? I don't have $1 million. I will probably never have $1 million. I am your teacher, right? Okay? So think about this for a second. I did some calculations for you this morning. You can understand the concept of 1 second, right?
Yeah.
How many seconds are in 1 minute?
60.
60 seconds in 1 minute. How many seconds are in 1 hour? 60 times 60, right? So it's 3,600. Do you know how many seconds are in a day? 86,400. So there are 31 million seconds in a year. 31,536,000 seconds in a year.
That seems like this one does.
Okay? So 1 million seconds is 11.57 days. So to get to 1 million seconds, we have to go almost 12 days. Okay? How long do we have to go to get to 1 billion seconds?
Oh, at least 2 years.
31.7 years. That's a lot, right? And for us, that's here. And then we're saying there's this many flowers.
You've never lived 1 billion seconds?
You have not lived 1 billion seconds. No, you have
That's
not.
so crazy. It felt like I have. Not yet. It feels like I have.
Okay. Suppose growing conditions for water hyacinths were actually ideal and they doubled every 6 days. Rewrite your equation, your formula, so that we start with the same 4 water hyacinths, but now we double every 6 days. What does that equation look like now? N over 6, right? N is just the number of days. It's just N over 6, right? Now you're answering the next question. Now you are. How many water hyacinths will there be now after 3 years? So that is 4 times 2 to the 1095 over 6, right? Put that in your calculator, please. I mean, unless you can do it in your head. If you can, that's fine, but... What'd you get?
3.46, 3.4676.
Is it okay if I stop at 4? Times 10 to the what power? 55th power. Just for argument's sake, I wrote it out for you. I don't know. Oh, here it is. Can't see it very well because it's in pencil, but it took me 3 rows to get all the zeros in there. Do you think that the formula will accurately predict the total water hyacinths population indefinitely? Or are there environmental conditions that might limit it?
How does it be environmental conditions that limit it?
You don't think it will predict it indefinitely?
No.
Why?
The things that happen.
Like what things?
Like droughts.
Droughts. Okay, so I want you to keep that in mind for just a second. So that's definitely an environmental condition, right? That might limit it. So let's write droughts. I almost wrote doubts. I don't think doubts would make water hyacinths go away, but what else might change that? Why is it not going to go indefinitely? Well, if we already have this many water hyacinths, is there room? So it would run out of room. And I don't mean in Florida. Stop. I mean, what do I mean?
In like the world.
Okay, look. You gotta stop. In the world, right? You think there's room for this many water hyacinths on the world, on the earth, on the planet? Okay, so room. It'll run out of room. Anything else you think might? Fire. What are those giant things that come to Florida that destroy everything?
Tsunamis, hurricanes.
Hurricanes. What did you say at first? Tsunamis, okay. Tsunami. I think that's how you spell it. If you are the environmental scientist in charge of reducing the population, what will you do to try to keep the water hyacinths from completely taking over? Poisoning the water. Okay, poisoning the water. I'm sure that won't hurt anyone else.
I was saying
like fish or people.
I'm talking like putting a certain type of something that would
Oh,
hurt just
so you have to develop a poison that's just for the water hyacinths.
Yes.
Okay? How long will that take?
about a year.
Oh, yeah, a year, you think?
A year or two, I don't know.
Okay. So it's definitely not instant, right? Okay. So poisoning the water in general would be a bad idea, right? But specifically targeting the water hyacinths, as long as it doesn't hurt anything else, okay, maybe that's a good thought. What else could we do? Oh, add predators. So adding predators, that won't do anything bad to anything else, the ecosystem, right? Oh, yeah, it might. What else could we do? I'm not going to write put will out there, okay? Because what is will going to do? What could Will do if we put Will out there? He could set them on fire, okay? Set the plants that are sitting on the water on fire.
Water fluid.
Have you guys ever seen water on fire before?
Yes.
Yes, it's a possibility. I'm not saying it's not a possibility. I'm saying, if you'll remember, we are an environmental scientist. Do you understand how many environmental issues we have with fire? Okay? Yeah? What else?
You can probably keep them out like some at a time.
Like on a date?
With a vacuum.
No, like you.
Oh, okay, vacuum them? So how are we going to vacuum up this many water hyacinths?
The big old vacuum.
A big vacuum. Okay, we need a big vacuum.
Huge vacuum.
Huge. But a little at a time is not a bad idea. Right? Little at a time.
Good idea, basically.
Okay? We could study them and figuring out what we need to do, right? Study them and figure out what we need to do. What?
That probably should have been first.
I mean, yeah, I'm not judging you. We're brainstorming here, right? Okay? I'm just happy that no one has said drop a nuclear bomb on them.
Oh.
Because that's been said
That
before.
would be a good one though.
We should put it on the list?
Yes.
Okay.
Yes.
Nuclear bombs. Because that won't harm the environment at all. Just a little radiation poisoning.
No,
Okay.
don't make it bombs. Just do one.
Just one bomb?
Yeah, just do.
So we want to bomb all of Florida.
Yeah.
Okay. So let me tell you two quick stories that are related to this. Not nuclear bombs, just this in general. Okay. In Florida, somebody had some pythons. They did release them. And what did the pythons do? It ate things and reproduced, right? And so there started to be too many pythons. In my opinion, one is too many, but that's just my opinion, okay? But it started killing a lot of things that pythons shouldn't be worried about, right? It started to really affect the ecosystem. And so Florida said, I have a great idea. We could pay people to kill the snakes, right? We didn't say that, right? We could pay people to pick up the... I suppose we said vacuum them up, and we need people to vacuum them, right? Well, we'll pay people for every python they bring us.
How many duggars?
What?
How many duggars?
So there was a whole lot of people that started collecting pythons. And except then the Florida government people realized that it was actually cheaper to buy pythons than the reward that they were getting. And so they realized people were raising pythons and killing them and bringing them in. They weren't going out and catching them. They were raising them for the bounty on the pythons.
That's smart.
it's smart but also dumb.
Didn't Texas do that with hogs at one point?
Probably yes. Okay. The other story I want to tell you about happened in Michigan. In the article I have is from 2019. Okay, so in 2019, and so in Michigan there's lots of islands, right? Think about what Michigan looks like, right? The pot holder and then the thing above there, but there's lots and lots of islands. Well, there's also lots and lots of moose. Moose. There's lots of moose, okay? And in the winter, it's fine because everything's ice up there. The moose can walk wherever they want. But when it's spring, it melts, and the moose get trapped on the islands. They can't go anywhere, right? So they do what moose do, eat and procreate, right? The problem was on some of these islands, the moose were actually dying from starvation because they'd eaten all the food source that was on these islands, okay? So what we decided to do, and when I say we, I mean the United States, what we decided to do was we got 4 wolves and sedated them and took them in a helicopter and hovered over the island and dropped them on the island. The wolves, dropped the wolves on the island so that the wolves could eat the moose. Right? So natural selection kind of thing, right? Keep the moose population down, keep the moose that are living there able to sustain themselves on the food that's there. The problem is that when it froze again, some of the wolves ran off. So in March 7th in 2019, we dropped 4 more wolves on the islands to help control the moose population. That was one of the things we said, right? Add predators. And the people studying this decided that was a fine thing to do. I just thought that was interesting and wanted to share that with you. You can look it up. I actually have the article saved on my computer. Okay? So it wasn't my decision to drop the wolves, right? It was those environmental scientists. That's what they decided. So we're not going to judge them because they studied it, right? Like Abby said, we should study it and make the decision, right? So I'm sure that that's what they did. They didn't just go with a helicopter and grab 4 wolves, right? Okay. All right. Look at number 12. Non-native plants can destroy an ecosystem. Non-endemic animals can do the same. This is another real story, okay? In 1859, 22 rabbits were imported to Australia from Europe. Before 1959, there was no rabbits on Australia. Okay? The rabbits found a land with plenty of food and no natural predators. Soon there were so many rabbits they were destroying the island. I need to make sure you understand here, I'm not talking about an island in the middle of Clyde Lake. I'm talking about the island of Australia. Do you understand how big Australia is?
Pretty big.
But there were so many rabbits on the island, they were destroying the island. Okay? In Australia, the rabbit population was doubling every 6 months. Determine in your group the important information from above so that we can determine how many rabbits there were at any given time. Real quick, talk in your group and figure out what the important information is. Okay, tell me some important information. Raise your hand and tell me something. What you got?
Plenty of food and no predators.
Plenty of food and no predators are 2 of the 4 things that I want us to underline. What you got?
22 rabbits.
We started with 22 rabbits. Excellent.
Well, you had a good one.
What'd you say?
I wasn't paying attention.
What's the one more thing that we need to underline? Doubling in 6 months.
That was what you had,
Okay. Explain how to calculate the number of years elapsed after 4 doubling periods.
2 years.
There's 2 doubling periods.
A year.
Per year. So 4 doubling periods, what am I going to do?
Multiply.
How many doubling periods in 1 year? 2. So how many?
By 2.
Divided by 2, right.
And you get 2
So 2 what?
years.
2 years. In 2 years, there's been 4 doubling periods. Does that make sense? How many doubling periods will have elapsed after 18 months?
That's
Yeah, 2
So 18 divided by what?
Six.
6 is what? 3 what?
no doubling period.
How many times has the rabbit population doubled after 4 years? 4 times what?
6.
How many doubling periods in a year?
3.
2. So 8 times? What about after 7.5 years? Will that still be 7.5 times 2?
Oh, yeah.
Equals what?
No, wait, yeah.
15 times? Okay so far? Okay. Let's fill in our table. How do our months go? By 6? So 1 month would be 6, 2 months would be 12, 3 months would be 4 months would be 6 months would be 8 months 48 and 10 months 60. Started with 22 after 1 growth period. 22 times 2, right? After 2 growth periods, 22 times 2 times 2. After 3 growth periods, 22 times 2 times 2 times 2. What about 4 growth periods?
22 times 2 times 2 times 2 times 2.
No, just 4 2s after the 22, right? And now how many? 1, 2, 3, 4, 5, 6. And now how many after the 22?
10 of them.
And now how many? 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to finish the rest. Okay? You're going to finish the rest. Any questions? If you need to come to Bulldog Period to talk about this, please just let me know. Have a great day.